Hello pre-calculus students, and welcome to the continuing series of videos on approximating and calculating areas under a curve. In this video, we are going to talk about the definite integral. So let's look at the definition of definite integral. The area between a function and the x-axis for a given interval. Any area above the x-axis is positive, and any area below the x-axis is negative. And you'll see this like funky looking notation here. This is A, this is B, and you'll see some function, and then you'll see like dx or dy or d something. So this is the left bound of the interval. Okay. This is the right bound. You have a function here. And then this dx is actually very important and often unreasonably neglected. It indicates the variable. It tells us what letter here represents the variable, not just constants in abstraction. So maybe we should look at an example, number 6 here. Let me block this off. The integral from 2 to 5 of x minus 1. So here's this function, x minus 1, and we want to go from 2 to 5. So we are essentially looking for this area here. Okay? Well, this is in fact just another trapezoid. Okay. Here is the height, has a height of 3, has a base. And to find the length of this, we simply substitute. This is really f of 2 right here. And this over here is f of 5. Okay. So that area is 1/2 the base, which is 3. I'm sorry, the height, which is 3, times base 1. F of 2 will give us 1, plus f of 5 give us 4. So the final answer is 5 times 3, which is 15, divided by 2 is 7.5. Okay. So that was number 6. Now, number 5, we can also do a similar thing. This is, if we graph this function, this is actually a half circle from -5 to +5. And we're looking for the integral from 0 to 5, so for the area of this region right here, which is a quarter circle, so that's pi r squared over 4, or it's pi, the radius is 5, squared over 4, so that's 25 pi over 4. Okay. So that's a very, very gentle introduction into the realm of integrals. There's so much more to this that we will explore in calculus and perhaps AP calculus. Next, let's look at an example of the sine function. So first, we are given this fact here. The area between the x-axis and one curve of the f of x equals sine of x function is 2. So we're going to prove this later, but for now, it basically says that this area is equal to 2. Okay. And again, we'll prove this later in calculus. For now, we can accept this fact and use it to solve a few problems. So number 8, let's sketch this out. Sine from -pi to +pi. Well, this is -pi here. This is +pi. And we're looking for the sum of the areas. But remember, so this area here is 2. This area here is 2, but remember, anything that is underneath the x-axis, according to our definition here, any area below the x-axis is negative. So that means we have -2 plus 2, so that's just 0. Let's try another one. Let's try the cosine function. It always helps to sketch these functions. So we want to go from pi over negative pi over 2, that's this point here, to pi, which is this point here. So we are looking to evaluate this particular area. Well, this area here is 2. This here is just half of the hill or the curve here for the sine function. So, and it's under the x-axis, so that's negative 1. So then this is 2 minus 1, which is 1. Okay. On your homework and your exercises, you'll find some more challenging problems to do, but these hopefully help to illustrate and give you an understanding of what the concepts are. Thank you for watching. Have a wonderful day. Remember to watch the video for the last example here.